All right. I guess it's time, isn't it? So, all right. I guess let's pull up an Inkscape and do some announcements, maybe. What's all this stuff? This stuff is 341 stuff, it looks like. Okay. Here we are. So, I guess next week is the exam 2 week. Exam 2 will be something like exam 1. I'll probably do a review tomorrow, Wednesday, most likely. So I'm thinking it's going to be something similar. So it's going to be some. It's going to be 1 week, and the topics on the exam are going to cover probably classes, maybe baby recursion. What else? What else have we covered since the first exam? I guess functions, a little, maybe, loops, obviously, but that's from the previous exam. That kind of stuff. I might also have some file input-output questions, maybe. So, yeah, dictionaries, probably. So yeah, I'll do a review next class, and then we'll have the exam next week. Yeah, I don't know, the binary hex decimal. I'll have to come up with a way to test it, right? And are you allowed to use with file I/O? I think the answer to that is yes. With is allowed. I haven't taught it yet, but I will teach it by the end of the semester. The thing about this class is that there's like so much stuff to teach, and very, very little time. Until like next week. So how about an extension on Project 2? Probably not. I'm going to try to avoid giving... I've been trying to avoid giving extensions. Well, the project was always due on Friday. Anyway, I'm not sure what I'm going to do. I'd probably... So just assume that there's not going to be extension. I hope that most people make some progress this week, and if you do, then that's good, and if like 5 people have turned it in, then obviously I'll have to extend, but I'm not happy about that, or wouldn't be happy about that. Okay. So, what other kinds of things do I want to say? I hear ya. So, here's the way the rest of the semester is going to go, from what I can tell. So, today we're going to do a bit more recursion. And we're going to do some maybe searching and sorting if I can do it. And then next lecture will probably not be searching and sorting. It'll probably be the exam review. And then I might do a little bit more searching and sorting after the exam. We're going to do maybe 1 day on asymptotic analysis. I'm going to try to make it as minimal of a topic as possible. In previous semesters, we'd always teach it, and then we would give it out to the students, and then the average on that part of the final was always like a 30%. And so that's, yeah. It always goes badly if we do it in 201. So I'm thinking I might teach it, and I will come up with a way to teach it and test it in a way that is much simpler than what was done in the past. So anyway, and so then we have, after this we have 25, then we'll have Thanksgiving, and then we'll have lecture 26, 27, 28, which is final exam review. So we have like 3 days of special topics or so. And so I will probably do, maybe I'll do some kind of web scraping, or, well, I mean, I had some ideas. I used to do some like GUI programming and maybe some web stuff like Flask or Django. I usually don't announce the topics until I do them, just because I don't want to hem myself in. Also, the other thing to say, I'm about to excuse me. Got it. So I'm very proud of myself. So the one thing to say is that what is the one thing to say? The one thing to say is that none of the special topics are on the final. Well, APIs are a general thing, right? An API is just an application programmer interface. So if I'm not teaching a specific API, like if I teach GUI stuff, I might do the TK enter API. If I do Django, there's the Django API, there's the Flask API. There's all kinds of APIs out there. The thing about it is that if I just say APIs, then it's it doesn't really mean anything, right? Because it's like, I won't be teaching anything. I'll be like, there are times when you have to call functions that are not your own. That is sometimes called an API. It's like, okay. Anyway. Yeah, so I think that's basically the end of the semester, right? So we do exam 2, and then we do project 3, and then we do the final exam week. Same as exam 1, right? Unless I decide to change it. Basically, I'm going to have there's going to be a small MCQ part, and then 50-point coding. At least that's what I did for exam 1. I have... you did not get the academic integrity quiz. I honestly haven't even had time to write it up. I think the right thing to say is just don't cheat, okay? Do not cheat. If you don't cheat, I mean, there's a part of me that almost just wants to give the academic integrity quiz one question. It's like, or maybe like 2 questions. It's like, did you copy off a Chegg? Yes, no. Did you over-collaborate with anyone? Yes, no. If your answer is no to both of those, you get 20 points. And if you lie, of course, that's when you get, can't lie. So, I mean, I really don't care about the academic integrity quiz as long as people don't cheat. Of course, we have had some degree of copying off of... Please give... I was just talking about it. Okay. What happened if you answered yes? Well, I guess... I don't know. God. Well, I mean, if I've already caught you and you answer yes, I guess that's not a problem. I mean, yeah. Can you cheat on the academic yeah, I guess technically, right? So, alright, that's enough of that. Let's get back to coding. So, What do I want to talk about today? Oh, and before you, don't worry about it, guys. Don't worry about it. I know. Okay. Okay. So, that's a good question. So I think I want to do some kind of branching recursion problem, maybe some pathfinding. Excuse me. And then maybe I'll start with sorting. So, yeah, let's just do some pathfinding stuff. So maybe let's do like, from random import choice. And then what we'll do here is we'll say, and so this, what we'll do is, let's build a grid. The grid is going to be, basically, let's say that it's empty, or if it's space, then, so let's define a constant, space, and so let's say, and then occupied is maybe x. And so let's build the grid here. For I in range rows, for j in range columns, and let's say grid equals that. We can do well, let's do it this way. Okay. Else. Okay. And then here we want to do, there we go. And then we'll return the grid. Okay, so this will build us a little grid. And let me just show you what it does. What does it do? Let's see. 10, 10.2. Let's make it 0.75. I think 0.75 is the probability of a space. So let's see what this does. There we go. That's pretty garbage. So the grid is equal to this. For I in range, the grid len. For j in range, len the grid I. Then what do? We just print out. Actually, we don't even have to do this. We can just print out the grid I. Empty string.join. That way it'll be the simplest thing. No, of course not. So, all right, so here's a little grid. Okay. So now let's state the problem. So what do we want to do with this, right? Maybe what we want to do is we want to find an exit, right? So let's say that there, I could, in fact I could. Something like that. I don't really like that, but I guess we could do that. Maybe we could do this. There we go. So what if we wanted to find an exit? So let's make an exit. Let's call it E, right? Capital E is the exit. So basically, right before we return, let's do a, let's pull in random int, and let us put grid rand int mod rows rand int mod calls is equal to E, which I guess should be a constant, right? Okay. So that should get us there. And so now let's see what this thing pops out. So whoops. Random missing 2 positional. Oh, I am not smart. I forget. Is it inclusive or is it exclusive? Let me just check. Python 3 inclusive. It's inclusive. So we want to do rows -1, calls -1. There we go. So, all right. So, and then let's pick another place. And make it the start. And of course, you might have something overlap. So I guess what we should do is say while I guess what x equals this, y equals this. And then we say while x of grid at xy is not equal to the end, colon. Of course, it's going to yell at me because I don't need those parens. Grid xy equals the start. There we go. Perfect. So here we have. Oh, there we are. So here we go. So basically here is where it ends and here's where you start. And let's think about how you could possibly get from the start to the end, right? So how would you do that? And the answer is, you know, you kind of did a RoboVac problem at one point. And let's make this. There we go. So, so we made a RoboVac problem at one point, but the problem with a RoboVac problem is that we saw that it got stuck, and once it got stuck, it never got out of the corners. And so it's kind of a, yeah, so this is like RoboVac recursion, but actually RoboVac recursion is like the right way to do it. And the reason why is because you notice that RoboVac got stuck in corners when shapes were bad. But you know, you don't want that. What you want to do is you want to be able to backtrack. And so let me show you how to backtrack using recursion. So I'm going to say, well, let's define a function, and that function will be called find path. And so we're going to feed in the grid. And so now what we're going to do is, or the idea here is we will find a path, and maybe we'll have a current position is equal to none. And remember what that means. I'll tell you what that means in just a second. It'll return the path to the, from the start to the end. And then the grid will be the grid. So, and what this is going to do is it's going to track through the grid until it finds end. And it's going to start at the start position. So let's think about this recursively. Like, what do you do recursively? It's basically the same thing that you were doing in the RoboVac problem. So the idea here is that you're basically, whenever you say, okay, I'm at this current position, what I want to do is I want to check to see which positions I can move to, right? Can I move back? Yes. Can I move down? Yes. Can I move right? Yes. Can I move up? It depends, right? Maybe you move up and then you detect that it's forbidden, or maybe you detect that it's forbidden and then don't move. So those are the two options there. And so a lot of the time, so basically that's the idea. What you have to do is you have to consider all possibilities for moves. And so the way that it works is that what you're going to do, so let's make a little helper function. For I in range, for j in range, what the heck have I done wrong? There we go. And so basically remember that this is a tuple. And so a tuple is going to be something with a parens on it. And technically else we return maybe none, right? So, all right, so we have to consider all possibilities for moves. So let's say basically when we call, actually I don't think we need this none here. We can get rid of this now that I've made a redesign. Let me put a pass in there. And so the call we're actually going to make is just, we're going to make a grid is just make, or what is it? What did I make that function? Build grid. Build grid. Build grid, let's build it at 1010, and then let's find path, a grid, find start. A grid. A tuple is a list, but you can't modify it. Okay, so this is basically the code we're going to run. And then in the very end, maybe we'll print out the find paths just so that I don't forget to do that. All right. So now that I've made all this helper code, I really just want to what do I want to do? I want to basically implement the grid path thing. So I want to say if current, let's say that, so basically x is going to be equal to current position 0 and y is going to be equal to current position 1. And so you can even do it like this. There's this multiple unpacking that Python provides where you can just do this as current position. And if it's a 2, the requirement is that this must be a 2-element array list tuple, and then it'll work. But anyway, so first we're going to check up. So basically if, and let's say that up is x minus 1. So if x minus 1 is bigger than or equal to 0, and that's just the bound checking, right? And if, what else? The grid at x minus 1 y is not equal to forbidden. Wait, what did I call forbidden? Occupied. Yeah. then what we can do is we can say find path the grid, and then the current position is going to be x minus 1 comma y. All right, so that's what we're going to do here. It is helpful. Basically here I have a find start, and, well, no, so it would be helpful, but we're not going to know it, okay? We're not going to know anything. And then, so this is like go up, and then instead, yeah, we're not going to prefer any direction, right? Because we could build, like, there could be some kind of random thing where, you see here, if you tried to just go towards the exit here, I mean, there is one path through it, but if you just said, oh, I know, let's say that the start was right here, and the exit was right here. If the start was here, it would definitely want to prefer this direction, but then the problem is there's two forbiddens in the way. So instead of making any assumptions, we're just going to pretend like the algorithm itself doesn't know where the exit position is. We tell it where the start position is at the beginning. It doesn't know where the exit position is. It definitely, this is not going to find the shortest path. Okay, so then the next thing we'll do, I guess, is if not, then, well, also, yeah, if not, then go left, right? So let's go left. And so what are we going to do? We're going to go, and what is left? Left is, yeah, if y minus 1 is bigger than or equal to 0, and the grid x y minus 1 is not equal to occupied, then we're going to find the path like so. Okay? And then if not, then go, I don't know, right, for no particular reason. And so here we have to change the error checking. Here we're going to have to say if y plus 1 is less than the length of the grid at x. And then here check that this is not occupied. Then move this direction by 1. And then else go down. And so find path the grid, and then, oh wait, but we still have to check the bounds. So we still have to check that x plus 1 is less than the length of the grid, and so then we're going to do x plus 1, y. All right. So notice that these are all the recursive cases, right? These are the recursive cases because this is basically like we're not at the end position. So we're going to keep looking. Is there a way to not give preference to a direction? I suppose. Oh, yeah. So, okay. So if you can't move in any direction, you print, help, I'm stuck. Okay? But before you do that, there's actually some stuff to do before you do that. So this is a non-recursive case, so we can return maybe empty list, and you'll see why I'm returning an empty list in just a second. But before we do any of this, actually we need some more cases. So if, say, the grid at xy is equal to, say, the end, what do? We're going to return well, let's return the current position, right? Because that'll be the last step in the path. And then you see here that this is our non-recursive case if we find the end, right? Because if we're at the end, so this means we're at the end. And then we have to decide something about all of these positions here. So let me just say print current position. This is not going to be the end code, but but let's just do it anyway. Okay. All right, so what happens if we do this? And let me just print out the current position. It's like entering current position. And so I want you to watch what's about to happen here. Boom. So what was the problem? Here's the problem. The problem is that it basically enters these long loops here. See, it's going, first it goes up, then it goes down, then it goes up, then it goes down, then it goes up and down, and it gets stuck. Right? So I'm guessing what happened was it got stuck between two places and it was forbidden, along a forbidden wall. And so the point is that we have to make sure that we don't go back to any position that we've already searched. This is, if we ever go back to a position that we've already searched, then it's possible that we can end up in an infinite loop like this. So one possible way to prevent this is that you set this, basically before you go into this thing, you'll just set the grid to x minus 1 and y equal to occupied. This is like, I think this is possibly the easiest way. Now this way actually messes up the board, so the board will not look right after you do this. But as long as you only ever have to go one path on the board, it's okay. So it actually doesn't cancel out the backtracking. What it does is you're allowed to backtrack up to that point, but you're not allowed to, if you're already at a certain position, you're not allowed to go to a position that you've already searched, right? So let's see what this does. Let's see if this fixes it. There we go. I guess it would have been nice to print out the board, wouldn't it? Because it's impossible to tell what's going on. Okay. So let's see. Help, I'm stuck. Okay. So what happened here? So it started here at the start, and then it searched, I guess, what did it do? 6-2. So if this is 7-2, it searched 6-2, which it shouldn't be able to do. And then it searched 6-1, which it shouldn't be able to do. And then it searched 6-0, which it shouldn't be able to do. And then it went to 7-0. Yeah, sort of. Okay, so why is it allowed to do this now? Like, what's the problem here? Because it's definitely not doing it right. Do I have some problem here? Oh, is this 7-3? Well, no, this is 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. So it starts at 7-2. And then the next thing it does is it goes to 6-2. So it goes up by 1. But that shouldn't be possible. So, so why should not? Why can it go up when it shouldn't be able to go up? If x minus 1 is bigger than 0 and the grid xy is not equal to occupied. So it can't be equal to occupied, but it is equal to occupied. So that's impossible, right? It shouldn't be possible. What's the problem? Let's think. Let's think. I mean, yeah, that would. I mean, okay. To stop that nonsense, I will print it, right? But that's not the issue. What am I doing here? What's the problem here? So it's entering this one, which is correct, because that's the start position. And then it does this, which it wants to go up first. But it cannot be, but it is equal to occupied, so this is false. So it enters the false condition, which doesn't make sense. And then it does more stuff, which doesn't make sense. Okay. Why is it entering? But it's, okay, print entering go down code. Oh, I guess we don't have the same grid again. So let's see, the start is here. Oh, wait, and it doesn't recognize that it found the end. Right? Oh, it thinks it's going up is -1. Yes, going up is -1. Yes, of course. So this is right. So entering 3, 6. Wait, why is it entering 3, 6? That's not even the start position. Huh. What is happening? And these are two different, way different boards. What is happening to me? Am I going nuts? I mean, what is happening? Those are two different boards. Like, what is going on? Like, this is not even the board after the path. This is just a completely different board. How is it making a new board? Because display shouldn't be making a new board. Display is just calling this code here. Oh! I am the dumbest human who's ever humaned. I had this line of code in display. Oh, wow. Look at that. That is... Okay. There we go. That confused me to absolute... I could not figure that out. Okay. Alright, let's see what goes on. Is this the same start board as the end board? More or less, I think, right? Yes, finally, okay. Alright, so what does it do? It enters here, and then it goes down, and then it goes back up. Oh, because it can't be start. So, I guess what we need to do is, yeah, we should probably set the current position to be occupied, just in case. There we go. That'll prevent it from backtracking. Okay, so let's see what it does now. Oh, well, that's stupid. Okay, so the entrance is, the start is here and the exit is here. So first it's going to go up, right? Oh wait, that's go up anyway. And then what is it going to do? Then it's going to trace back and back and back, and then it gets stuck. And then is 1/8 the correct answer? There we go. Okay. Let's see if this... Wow, look at that. Beautiful. So now it's searching better. Oh, wonderful. Look, it can't get to the exit, but now it's doing it right. Okay. But anyway, so this is actually correct now. You notice what it did. So what did it do this time? It actually kind of traced its way through, and it couldn't get to the exit because the exit had forbiddens all around it. So this is actually it working correctly. So now let's do it. Let's do it again, and it'll generate a new map. Okay. So hopefully 4-6 is the place where the exit is. It is not. Yeah, I guess all we have to do here is just say that the grid is equal to space, and then we can add that in. That's a different way to do it. Yeah, of course I'm definitely confusing everybody, and this lecture has gone badly because that stupid display thing. The problem wasn't even in this code; it was in the display. It was generating a new board every time you printed out a board. So hopefully the end is at 5,5. It is not. So that's great. Yeah, thanks. So entering 5,5. I guess that's the start. Oh, it's because here... Maybe we need to have a found exit. So let's change this to step. Step equals 0. And then what we can do here is add 1 to the step. This way we can track our step. Of course, if it goes too high, then... Okay. Let's see what it does now. Oh, wonderful. Let's take all these out then. Okay. There we go. Okay, well, so here's an example of where it's kind of doing something right. It's starting here, and then it goes 1, 2, 3, 4, and then it's stuck. So this is correct. So let's see what it does now. Let's do another one. Blurg. So, okay, let's see what the original grid was. Here's the start, and here's the end. So what is it going to do? It is going to start here, then it goes up, 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 and then it can't do anything. How did it go over? Oh, I guess it's because, yeah, unfortunately, that's not actually diagonal. That's straight up. And so is that. It's because of the double digit thing. And so here, then it's searching this direction, and I think it's finding forbidden positions. And then it's going back here, 10, 11, 12, 13, 14, 15, 16, all the way up 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, yep, 28, 29, 30, 31, 32, 33. And you see here, Oh, well, maybe we should do it if it's not equal to the exit. So return true, I guess. That would be a good way to do this. And then here what we'll do is we'll set this to the step. If it's not equal to the exit... Wait, what have I done? Okay. So if find path, return true. And then here, if find path, return true. And then same thing here. If find path, return true. And then finally, if find path, return true. And so here it shouldn't, okay, that's good. It doesn't overwrite the exit now. So basically, what does it do here? So here, here's the start and here's the exit. So it has to kind of trace its way this way. And so what is it going to do? Is it's going to say 1, 2, and then it finds a forbidden space. So it goes 3, 4, 5, goes up 6, 7, 8, 9, and then it finds this forbidden space. It can't go back up because that was not allowed. So it goes over 10. This is only because of the digit issue. I guess what I should do is I should say, maybe we should do, terrible. Right, we need to modify display again. Oh, wonderful. Have to do that. Okay. There we go. This is a little bit better to see. And so what are we going to do? So where's the starting position? Starting position is here, end position is here. So what we're going to do is we are going to start here at 0. It goes up, up, over, over, over. Then it can't go up or over anymore, so it goes down. And then you see here, it traces into here. The step here is 8, but then there's forbiddens here, so it can't go in there. And so then it pulls back out of that recursion, and it does this. It goes here, 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 17, 18, 19. And then, of course, what does it prefer to do? I guess, does it prefer to go down or to go right? I thought down was the last thing it wanted to do. Oh! It avoided the end because it didn't want to go to the end because it's not space. See, that's why I was trying to be careful to not do that. Okay, there we go. This is much better. Yeah, I didn't realize why I was avoiding hitting the end. I was like, what's going on? So, so where's the start? Start's here, end is here. So let's see what it does. So it traces up, over, up, over, up, over, and then of course because it wants to go up by default, it's going to go up, and then it's going to trace this way, and it's going to go all the way in here, and it finds all these forbidden spaces. So basically it backs out here, it goes back to here, right? This was step 12, and you see how this was step 13, but this is step 13 along a failed path. This is step 13 along the good path. 14, 15, 16, and then here it had another thing where it decided to keep trying to go this way, so 17, 18, 19, 20, 21. And then here basically it failed because it's all forbidden and it couldn't go back. And so what is it going to do now? So then it backtracks to here and it tries to go down. 17, 18, 19, 20, 21, 22, 23, 24, 25. Can't go this way. This is forbidden. So then it goes down, 25, 26, 27, 28, 29, the end. So after all that time, it finally found the end. And so this is a general thing to, let's actually, I have an idea. Let's watch it do what it's doing. Okay. Yeah, I mean, it's kind of dangerous to live code something like this because it's a little bit delicate. But on the other hand, it actually eventually worked. So why don't we display the board, and then we will input continue. And I guess I don't really care what you input as continue. Maybe if continue is not equal to y, then quit. Now quit is forbidden, but I'm going to use it just because I want to use it. Just because this part here would not actually end up being in your project or anything like that. Now this is. So let's see. So we start out. Where do we start? So we started here. So here's where we start. Continue. Yes. And so okay. Continue. Yes. Wait. What? What's happening? Oh, now it's gonna explode on me. Ah. Sorry about that. It didn't like something about my input, and it died. So let's see. Continue. Yes. Continue. Yes. So now it's going to go up, 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 up. Right. So it went up, 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 and now we want to continue again. So what are we gonna do? I think we're gonna go right next. Yes. Oh, I'm sorry. Left. Yes. Yes. And now it cannot continue in this direction, so it's going to kind of snake this way. So it's going to snake down for 1, I think. And then it's going to try to go up, but it can't go up. It's going to try to go this way until it gets into this. So yes, yes. And now you see what happens. You see here it says going left didn't work, going left didn't work. And what did that mean? That means that at this element 10, it found out that, oh, I'm in the middle of all these forbiddens, and also if I try to go back this way, it's already been marked. So because it's already been marked in this direction, and I've already gone, and I can't go these ways, that's why it says it twice, because it returns twice. It says, I'm going to pop this one off, I'm going to pop this one off, I'm going to go back here. So now let's continue again. So now you see that this was step 9, but this is a bad step 9. This is a good step 9. So now we're going to continue again, 10, 11, and it can't hit through this 2, so now it's going to start going down, maybe? Or maybe it'll try to go up for 1. Yeah, it's going to try to go up, but then it said going up didn't work because it found all these marked positions. So now it's going to start going down, and let's see what it does now. So now I think it's going to go over, 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 up, I guess, and over. And then it's going to say going left didn't work, going up didn't work, right? Because you see that this position says that it didn't work to go left because here it didn't work, and then here it didn't work to go up because this position didn't work. So now we're back here. So now it can't go back this way, so it has to go down. So let's continue. 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 So it's going to snake for a while. Ah, here we go. And now hopefully it's going to go up, because up is better than down. Up, over, up, up again, over, over, over. And now it's forced down, because all the other directions are forbidden. Okay, so now it's stuck again, so it's going to be like, I don't like this. it said it right here. Going left didn't work. So now we're back. So you notice how this is step 36, and now this is step 36. So here, that's step 37, 38, 39 is up, but now it's stuck in forbiddens, so it's going to go down, or I'm sorry, it's going to go over, over. And so this is pretty bad, right? Because it's going to search all of this space and find nothing. And so you see here, to make the paths? What do you mean by make the paths? Like mark them? Mark them with something else? We could do that. We could always put like a bad... Yeah, we could do that. We'll do that next time. And so then here, you see, it went all the way back to step 40, because 41, 42, 43, 44, 45, 46, 47, 48, 49, and 50 are all in this blob, right, of crap. And so that's the issue, is that they're all in this blob where it's just not working out. And so maybe we'll change them all to like -1s or something. And so now it's going to start at 40 again, so it's going to go down. Now over, down. You see, it's really trying not to find the exit, because finally it gets forced into doing it. It's going to go up, up, and then finally over, over, gets forced down, gets forced this way, and that. So, if the path didn't work, you want to mark it. So why don't we mark it if it didn't work? The grid, x, y, no, x minus 1y is going to be equal to, say, -1. Or maybe we'll just mark it with bad. Is there a lot more code necessary to find the shortest path? Yes. No. I don't know. I think it's about the same amount of code, but it's a completely different way of attacking the problem. Yeah, it's a lot different. So let's do one more of these. So let's hope that this finds it easier. So continue. There we go. Oh, it's gonna find it. Look at that. It found it. We done. Right, because it started at 0, went right to the exit, and it knew what to do. Let's do another one. So this is one that it's definitely going to have a lot of problems. So, okay, let's see what it does. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good, it trapped itself. So 13, 14, 15. There we go. So now all of that is marked as bad. Right? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, bad. 25, 26, 27, 28. Wait, where did... Oh, 28 was bad. 29. 30's going up. Oh, it's terrible. It's going to miss. There we go. 35, 36, 7, 8, 9... See, and it marked these as bad because those were both stuck. And so now it's going to go 39 this way, 40, 41, 42, 43. It's really trying to snake its way down. So, almost there. Come on. Wait, where is it? 54. Yes. 54, and it found it. Yes. Good. So you see that this is possibly one of the worst paths that you can possibly find. But the question is just like, did it do it? And the answer is yes. I'm not sure how much we're going to make. I just want to show this guy to you people. I want you to like understand it. I might make like one homework problem about it. I mean, I've already made RoboVac about it. So basically, I mean, technically, really, you should recognize this code, right? This code is almost RoboVac. It's just we've added recursion. And what does recursion allow us to do? Recursion allows us, instead of getting stuck, whenever we got stuck with RoboVac, to avoid the infinite loop, we just stopped. But with recursion, what it does is it allows us to actually backtrack. And I will say that this is... I'll say it this way. Do you need a recursive solution to solve this problem? No. Are the best solutions of this problem, do they involve recursion? Yes, most of the time. So to find the shortest path, it requires something called a breadth-first search. And so let me show you how let me think for a second. So how does breadth-first search work on this grid? So what you have to do basically in a breadth-first search is that you have to search every position at a certain distance away from your start. And so the way you do it is you'll say could Dijkstra's algorithm be helpful? Yeah. But Dijkstra's algorithm, so the difference between a breadth-first search and Dijkstra is not equal to BFS. Breadth-first search is definitely out of scope for the course. Dijkstra involves weighted edges. So basically, Dijkstra finds the cheapest path. If, for instance, it would cost a different amount to go from this 4 to, say, this 5, rather than this 4 to this 3, or this 4 to this bad, right? So that's what Dijkstra does. But that's kind of the point here, is that that's why we're not going to be doing Dijkstra. So, okay. I guess let's actually do the breadth-first search, because I'm not going to do... I'll do sorting after the exam, so... So yeah, because sorting, it will be the only really new thing on the final then. So we'll do exam review next time. So let's actually do BFS. And this is a different way to think about the problem. So this way thinks about the problem by going up, over, blah, 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 right? So what we're going to do in this case is we're going to think about... The way we have to think about the problem, you want to search all positions at a distance d before you go to distance d plus 1. So that's what you want to do, okay? And so sorting and algorithmic analysis, big O. Which anyway, so how do we do that? So basically what I'm going to do is I'm going to create something called the search. Maybe, yeah, we'll say, I think we'll create a search list, is an empty list. And so we're going to find the start of the grid. And what we'll do, the start is equal to the find start. And then what we'll say is that we'll append this. And then we'll say while search list Yep. And so what we're going to do here is we're going to say if, basically we need the same kind of code, but we're going to just use append. So search list, if the grid at, say, x minus 1, y is not equal to, or is not in, space, the end, then, actually, let me copy paste the code. I think that will probably be the best way to do it. And then we can modify it. So here what we'll do is we'll say, so x, y is equal to the first element, so search list 0. And then what we're going to do is we're actually going to search list.remove like that. And so what would, instead of doing this, we're going to append list with all the possible moves in a for loop. Yeah, I guess you could do that. Let's keep deleting code, and then here we're going to go search list dot append. What is this? X, y plus 1, and then finally what we're going to do is we're going to do search list dot append x plus 1 y, and you see that it's kind of doing the same thing, but on the other hand. So actually, the thing that we implemented here is basically a depth first search. That's what this is really called. So the breadth first search does it a little bit differently, because what it does is it let me think for a second. Yeah, I guess that's one way to do it. Yeah, I guess we need to actually make sure that the search list is sorted by depth. So, so here we'll do D for depth, and then we will do this. So we'll append 0 the start. And so here I'm going to say depth There we go. And so then what we're going to do is we're going to append this, and then we'll append this, and then we'll append this, and then we'll append, because it's possible that, I guess it's technically, is it possible that we're going to append things? So, okay. And then what are we going to do? So this is while search list. We're going to do this, and then we will mark. Let's mark the thing so that it doesn't keep doing it. So this will prevent infinite loops. So I think this is what we should do. Let's see what this does. I'm a little curious because, I mean, I think it might just explode, but who knows? And then at the very end, we should just do Oh wait, we want to do. Let's get rid of this, and then let's do breadth first search on the grid. What's the problem? It doesn't like that. Oh, because we didn't create. Oh, a grid. Excellent. Int object has no attribute blah. Oh, look at that. Look at that. Hey, it didn't crash. It didn't crash. So here's the start position, right? And here's the end position at 9 right here. I guess basically if we found, I guess the only thing is like if we find the end position, we haven't actually done that. So if the grid at x, y is equal to the end, then we can print out found it and return. Okay. So let's run this again. So let's see what happens. So the start is here. And so in order to find the shortest path, what you do is you find your way to the end. And so what you're going to do, so you see here how what this is doing here is it's saying this is depth 1. These are all depth 1 or distance 1 or whatever you want to call it. This is distance 2, 2, 2, 2, 2, 2, 2. And you notice that there's nothing in this direction. And so then here, since you can't go this way, this is distance 3. Right? Distance 3 away. And then when we get to distance 4 away, all of these are distance 4. This one's forbidden, so it's not 4. This one's forbidden. This one's distance 4, distance 4, distance 4, distance 4, distance 4. And then what happens? So then what happens is it goes to distance 5, and it puts on this one, this one, this one, this one, this one, and then it finally gets to this 4 here, and when it pops it off it's technically a stack, it'll pop it off, and then it'll find the E. So once it finds the E, it says found it. Once it finds the E, it says found it, and then it stops. That's how we know. And then how do you find the shortest path, right? How you find the shortest path is what you do is you say, you start at the E, you look for the smallest number around it, which is going to be the only number, hopefully, around it. And so it says it's a 4. And then you say, okay, there's 2 3s. Whichever one is fine. You just go, there are 2 shortest paths in this case, right? You go 4, 3, 2, 1, 0, or you go 4, 3, 2, 1, 0. And those are the shortest paths. And you notice that they're equal length because this is 1, 2, 3, 4, 5. This one's 1, 2, 3, 4, 5. Right? So they're both the shortest paths. So this is how to find the shortest path using a breadth first search. So I guess that's what I taught today. I need to rename this lecture entirely. It was this lecture is really, we should call it the grid, right? This lecture is all about traversing grids. I think that doing this is a very important thing. I'm not sure exactly. Yes, it did. Yes. I mean, I'm apparently just not naming any of the lectures correctly. I did intend to do, so I did recursion, I just didn't do any classes today. Yes, it's all about the grid. I mean, sure. That's definitely a job for you, right? So, I mean, I didn't actually retrace the path to actually find the shortest path, but you can do it either iteratively or recursively just by saying you start, I don't even know what extra credit is. Yeah, of course, everybody needs more instruction on classes. I agree. But you also needed this instruction on recursion. And as you see, I teach mega slow because I did this during lecture a few times, and it took me about 30 minutes, and this took me 75 minutes. So, granted, I live coded all of it, so I found I created a whole bunch of bugs. I think that teaches me a lesson not to do that in general. This block of code right here is very finicky. It's very finicky. You have to be very precise. Actually, look at this. The breadth first search was shorter. I mean, of course, I'm cheating and using this .sort. I'm not 100% sure. I'd have to think about it if you actually need it, but I don't want to. I wanted to make sure that the algorithm worked, and so I know that this has to be sorted by depth. If it's not sorted by depth, then you have a problem. Actually, let's see what happens if you take this off. And it basically still worked. Yep. It may not work in certain cases, but I think it's working in this case. Okay, well, so this lecture was about grids. So that's what I'm going to rename it. Let's rename it. Pathfinding on the grid. Okay, cool. So now the lecture's renamed, which is good because it's right now. So this week's lab is going to be about classes. It's more class practice. It's actually almost it's like a clone of the homework problem, but that's what it is. All right, I guess I'll let you all go. That's all for today. I'll upload this to the GitHub so that you guys can all look at this. Why don't I rename this lecture? Because the file. So let's see, rename. Where's rename? I always lose things in this menu. Let's just show it in Explorer, and then let's rename it here. And then it will rename itself. Is that see, renaming a file is not really refactoring code. That's why it's not the right name. That's why it always confuses me. Let's see here. Commit. And now let's upload it, because otherwise I always forget. Push. All right, there we go. So I think that's it for today. I think I'm gonna have to... The problem is that there's always more things about classes, and there's always more things about recursion and all this stuff. The whole goal of this lecture was to basically get you guys to think about how to traverse a grid using recursion. And so, okay. You know, there's something, there's like too much honesty, right? I always say that honesty is the worst policy, and in this case it definitely is. So, alright, I'm gonna let everyone go now. Talk to you guys later.